Hello friends, this is Ranjit Joshi. Welcome to this lecture series on a topic Mechanics of Structure, which has a course code of 403 in the 4th semester RGPV syllabus and scheme. So the topics which I am going to cover in this lecture series are the basics, the mechanical properties of materials, simple stress and strain, stress-strain diagram of mild steel and other metals, as well as stress-strain diagram of HYSD bars. But before embarking into these topics, I would like to ask you one fundamental question, that do you think materials are important in civil engineering? If yes, then why? That is a very important question you must ask yourself. Now, if I ask you the role of civil engineers, then we know that the role of civil engineer is to design structure which is safe as well as serviceable in the intended period of life. So, what do we mean by that? We mean by that is that the structure is going to remain safe on the applications of external loads, and it is also going to remain serviceable on the applications of external load for the design period for which we have designed the structure. Now comes one more question, that when we say the structure is going to remain same, what are we doing? We are designing structural element using different engineering materials. So in order to make safer structure and serviceable structure, we need to understand the fundamental properties of materials. That is why this subject also play a crucial role in understanding the designing principles of civil engineering. So let's begin with the basics. So first of all, we need to understand that in engineering mechanics, we have learned concepts of statics and dynamics, and now this subject is the strength of materials. So now we need to understand that what happened in statics and dynamics. In statics and dynamics, we have learned about the effects of external forces, and we have calculated the external reactions. Whereas in this subject, which is mechanics of structure, we will be more focused upon the internal effects of the structure. So here also the external loads will be acting on the materials, but now we will be calculating the internal effects of those external forces. So this is a fundamental difference in between the mechanics, statics, dynamics and mechanics of structure. So here one more concept is there which I want to explain, which is a concept of rigid body, which is also in your syllabus. So first of all, we should ask ourselves, what do we mean by rigid body? So rigid body is a body which showcase zero deformation on the application of external loads. This is a very important concept. Now ask yourself, do you think in universe there exists a rigid body? The answer certainly will be no. Rigid body is a hypothetical concept which we use in mechanics in order to solve problems for different end reactions. There is no body in this universe on which when we apply force and there will be zero deformation. So similar to rigid body concept, there is a ideal fluid body concept. So what do we mean by ideal fluid? So ideal fluid is a scenario in which there will be no application of external force and there will be continuous deformation. So this is also very important concept. Now why am I teaching you the concepts of rigid body and the concept of ideal fluid in this lecture? Because if we plot graphically the force on the y-axis and deformation on the x-axis, then the rigid body will be represented by the y-axis, whereas the ideal fluid will be represented by the x-axis. Why so? Because on the y-axis you know that deformations are zero and forces are increasing. So this is the case of rigid body, because here we are assuming that on the application of enormous amount of force, the deformation will be zero. Whereas on the x-axis, the deformations will be continuous, but the force will be zero. So this will be the case of ideal fluid. But in real life, whatever materials we will be using for designing different structural elements which are pertaining to this particular subject, we will be using scenarios which will be lying in between y-axis and x-axis. So this is a very important concept which you need to understand. Now let's learn about some more concepts in this topic. So these concepts are external forces which are acting on a body, and then the internal forces which are acting on a body. So the external forces which are acting on the body are the forces which act superficially or on the surfaces of the body. For example, suppose we have a plank and a person is standing on a plank. So this person is going to exert self weight on this plank. So this self weight exerted by this person comes in the category of external load. Similarly, if this plank is situated on two blocks, then these blocks are going to generate reactions. So these reactions also comes under the category of external forces. Now comes the internal forces. So what are internal forces? Let's learn. So suppose we have this body and I am trying to pull this body from both the sides. Then what is happening? Inside, in the molecules of this material, the stretching is taking place. So this stretching is taking place because of the tension or tensile force. Similarly, if I am pushing this book from both the sides, then what is happening in the molecules? The molecules are trying to squeeze each other. So there the compression is happening. And then when I am applying a force which is parallel to the surface of this body, what is happening? Then the shear is going to happen. So either tensile force is going to generate in this body, or compressive force is going to generate in this body, or deformation, angular deformation is going to take place in this body due to the shear force. So these are the internal forces. Now let's learn about the mechanical properties of material. Now we should ask ourselves, why do we call these properties as a mechanical properties? We call them mechanical properties because these are the properties which are exhibited by the material on the application of mechanical loads. So now comes the question, what do you mean by mechanical load? So mechanical load is any external load which for application requires contact surface. So these are certain properties which comes under the category of mechanical properties of material. So the first property is strength, then we have elasticity, then plasticity, then ductility, brittleness, then malleability, stiffness, toughness, hardness, isotropy and homogeneity. Before defining these properties, I would like to mention one point which is very important, that as a civil engineer, we all must acknowledge the fact that whatever properties materials exhibit, those properties are always going to remain constant. For example, suppose if today concrete is good in compression, then it is going to remain good in compression all throughout its life. Never this is going to happen that today concrete is good in compression and tomorrow it will become good in tension. Same with the mild steel. If it is good in tension today, then tomorrow also it is going to remain good in tension. So these properties are the intrinsic properties of the material and they play very crucial role in the design of various structural elements. Now let's go and define them one by one. तो सबसे पहली जो प्रॉपर्टी है वो है स्ट्रेंथ. सो स्ट्रेंथ इज द एबिलिटी ऑफ अ मटेरियल टू रेजिस्ट लोड विदाउट फेलियर और इट इज़ द अल्टीमेट लोड कैरिंग कैपेसिटी ऑफ अ मटेरियल बिफोर रप्चर. तो इसे हम इस तरह से समझते हैं, क्या कोई भी मटेरियल ऐसा होता है जो इनफाइनाइट लोड ले सकता है? आप कहेंगे नहीं, कोई भी मटेरियल ऐसा नहीं होता है जो इनफाइनाइट लोड ले सकता है. हर एक मटेरियल की डिफरेंट लोड कैरिंग कैपेसिटी होती है. कुछ ऐसे मटेरियल होते हैं जो बहुत ही कम लोड लेके टूट जाते हैं, कुछ ऐसे मटेरियल्स भी होते हैं जो बहुत ज़्यादा लोड लेते हैं, कुछ ऐसे मटेरियल्स होते हैं जो बहुत ज़्यादा कंप्रेसिव लोड ले पाते हैं जबकि टेंसाइल लोड बिल्कुल नहीं ले पाते हैं, जैसे कि कंक्रीट. और कुछ ऐसे मटेरियल्स होते हैं जो टेंशन लोड्स बहुत अच्छे ले पाते हैं, उसके साथ कंप्रेसिव लोड्स भी ले पाते हैं, जैसे कि स्टील. तो यहाँ पे एक चीज़ और हमें समझनी है कि जब भी हम कंक्रीट का ग्रेड लिखते हैं, जैसे हम लिखते हैं M15 या M20, तो इसमें जो नंबर 15 या 20 होता है वो उस कंक्रीट की कंप्रेसिव स्ट्रेंथ बताता है. सो स्ट्रेंथ एक बहुत ही इंपॉर्टेंट पैरामीटर होता है जिस पे स्ट्रक्चर की सेफ्टी बहुत ज़्यादा डिपेंड करती है. तो हमें ये बात समझना होगा कि ये उसकी अल्टीमेट लोड कैरिंग कैपेसिटी होता है फेलियर से पहले. अगली जो प्रॉपर्टी है जिसके बारे में हमें समझना है वो होती है इलास्टिसिटी. सो इलास्टिसिटी इज अ प्रॉपर्टी बाय वर्च्यू ऑफ विच मटेरियल इज गोइंग टू रिगेन इट्स शेप एंड साइज ऑन द रिवर्सल ऑफ द लोड. अब यहाँ हमें ये चीज़ समझना बहुत ज़रूरी है कि ऐसे बहुत सारे मटेरियल्स होते हैं जिसमें जब हम लोड लगाते हैं तो या तो उनमें एक्सटेंशन होता है या कंप्रेशन होता है. तो इलास्टिक मटेरियल्स वो मटेरियल्स होते हैं जिसमें उन एक्सटर्नल लोड्स को हटाने पर वो मटेरियल अपने ओरिजिनल शेप एंड साइज में वापस आ जाता है. अगली जो प्रॉपर्टी है वो होती है प्लास्टिसिटी. प्लास्टिसिटी का मतलब होता है परमानेंट डिफॉर्मेशन. तो कुछ ऐसे मटेरियल्स होते हैं जिसमें जब हम एक्सटर्नल लोड लगाते हैं तो शुरुआती तौर पे तो वो एज अ इलास्टिक मटेरियल बिहेव करते हैं, बट लोड की वैल्यू एक पर्टिकुलर वैल्यू से एक्सीड हो जाने पर उनमें परमानेंट डिफॉर्मेशन आ जाता है. अब बहुत थोड़ा लोड लगाने पर भी वो मटेरियल फ्लो करता है. तो इस प्रॉपर्टी को प्लास्टिसिटी कहते हैं.